Hi guys! Hi everyone! Welcome back to part 4 of my mini series. So, this is my first question that I'm gonna leave up on the screen while I just move you all around. I would like to know, what is toad vomit good for? Please tell me, and I hope you like my picture of my psychedelic toad up in the top right hand corner. So, on the chat, what is toad vomit good for? Vendible Sugar has put digestion of food. Of whose food? Am I digesting the food and then the toad vomit? Or is the toad having the vom for the food? So, what can toad vomit be used for? Please tell me. It's quite an old use. I wouldn't say people use toad vomit for this now. Although I would make friends with this psychedelic toad. He looks pretty cute. The answer, let's go to my next slide, is this is a page from a book in 1667, and this was written by Sir Isaac Newton. And in 1667, Sir Isaac Newton wrote a treatment for the plague, which was toad vomit. And it was written here in this book called De Peste. And it was all about different ways to treat the plague. And I've got the extract of how he describes it, so I'll just tell you now. So Isaac Newton wrote, quote Isaac Newton here, "The best is a toad suspended by the legs in chimney wax for 3 days, which at last vomited up earth with various insects in it onto a dish of yellow wax and shortly died after. Here you must combine powdered toad with the excretions and serum made into lozenges worn around the affected area to drive away the contagion and draw out the poison." So, Sir Isaac Newton, clever dude, wanted you guys to crush up bits of toad vomit with a dead toad and wear it round your neck. Vendible Sugar put, did it actually work? We're going to say no, okay? We're going to say toad vomit isn't a great cure for the plague, but you guys might laugh at this. These pages are actually selling for like £64,000 to £100,000. These pages now. So yeah, some expensive knowledge, I guess. So, if you guys have just joined, welcome. But in the first lesson of the little series, we did what is cancer. So it's DNA, mutations in your DNA that make your cells grow really fast. Number 2, we learned that things like smoking and alcohol and bathing in the sun can increase your risk of getting cancer. We also, on the second week, did different ways to diagnose cancer. So things like MRI scans and PET scans. And then last week, we learned about things like chemotherapy, radiotherapy and surgery. But this week, we're going to be doing a whistle-stop tour of some super cool ways we can treat cancer at the moment, one of which is the Bublés. So my question to you is, how can bubbles help to treat cancer? How am I using bubbles to treat cancer? Hint, it's not this kind of bubble. That's the hint I'm giving you. Pardon me. Ms91 has put Michael Bublé, Michael Bubble. It is nothing to do with Mr. Michael Bublé. So, how can bubbles help to treat cancer? What am I doing with the bubbles? So, Ms91 thinks we can put a bubble in a cancer cell and blow it up, and then it explodes. You're close, okay? You're pretty close. So, to start with, we have to look at how big a bubble is. So, here is my regular bubble, and I've said for argument's sake that a regular bubble is like 2 centimetres big. So this, I guess. That's a regular bubble. But we're not using these bubbles. We are using a special bubble called a micro bubble. And these are 1 to 10 micrometers big. And just how tiny that is if we've got 1 metre, then we've got centimetre, then we've got millimetre, then we've got micrometre, and then we've got nanometre. So a nanometre is a billionth of a metre. So when we're talking about down this end, things like micrometers and nanometers, you cannot see them with an eye. Like, I would not be able to see a 10 micrometer bubble with my naked eye. You have to use a microscope for like micrometer things and nanometer things. So these are super, super, super tiny micro bubbles that we cannot see with our naked eye because they're so tiny. So what am I doing with these bubbles? So what I do is I get these micro bubbles, these micro Michael Bublés, and I put chemo drug inside the Michael Bublé here. So the red is my drug. Then I inject these bubbles into my person. And when these bubbles get to the tumour, what I do is I use an ultrasound to pop the bubble. The bubble then releases all of its drug around the tumour, which is super cool. So we are using ultrasound, which are sound waves, to pop these little micro bubbles. They release the drug around the tumour, which is really, really cool. So this helps to, it like stops the drug from getting to places where we don't want it to get. And it means we can like force it inside the tumour a bit more and maybe spare some of the normal tissue that's not a cancer. So, Messi the best 10, 10, 10, 10. What does ultrasound mean? Ultrasound, remember X-rays are a type of radiation. Ultrasound is just using high-powered sound waves. So it's like when pregnant women go for an ultrasound, it lets you see things inside the human body using sound waves. So we would take this here, this machine, it gives off sound waves, they bounce to the body and they get bounced back into this little detector and we can kind of see what's inside the body. So it's using sound waves and how well they bounce off things in your body to create a picture of what's inside your body. But some crazy physicists and scientists figured out that ultrasound, it pops microbubbles, which we can use to treat a cancer. So this is how microbubbles work. We can put extra drugs inside them, use sound waves to pop the bubble and force the drug inside the tumour. So there's the answer to your question. Lesson done. Finished. That is how bubbles treat cancer. And now I want to talk about some other super cool things we use in cancer research. So another question I have for you guys is, how can we use a virus to kill a cancer cell? I'll leave the question there for you in the chat. How can we use viruses to kill a cancer cell? How do you think that would work? Mears is saying we can train viruses like dogs. Close. Vendible Sugars put it infects it and kills it. Not a Robot 1997 says it explodes them. Yeah, you guys are like kind of right in a very general way. So, first, Mears 91 has put and then reward them with treats. So, this is the structure of a virus, okay? Now, my question to you is, are viruses dead or alive? This is, I think you guys get asked this at school quite a lot as well. Are viruses dead or alive? What do you guys think in the chat? So this is a very general structure of a virus. It's got its own DNA or RNA inside. It's got some enzymes in there to help it replicate, so to divide. And it's got these special spike proteins on the outside. And these spiky proteins help it to stick and gain entry into your cells. So these spike proteins will stick to your cells, and that's how the virus gets in. So everyone's gone dead, dead, dead. Miz is 91, done this with Matt, they're dead. Vendible Sugar has put alive, just throw a curveball out there. So, are they dead or... Viruses are like the weird zombie of biology world. So, I would technically say they're dead because they cannot replicate on their own, right? So a virus has to gain entry into your body, into your cells, and use your machinery inside your cells to replicate, because it needs you, your body, as a host. So a virus cannot replicate on its own, which is why I would argue they are dead. But feel free to argue with me, guys. So, this is a virus. They're quite simple, just a bit of RNA or DNA inside with spiky proteins. So how do we use these to treat cancer? So all we do, and I make it sound really simple, we genetically modify a virus. So what we do is we take it to the lab and we remove the genes that cause disease. So all of the like infectious part of the virus, all the nasty disease causing bits of the virus, we remove. And then what we do is we put extra genes or extra bits of DNA into the virus so that they can recognise the tumour cell and not your normal cell. So we're kind of doing like a seek and destroy. We're genetically modifying a special seek and destroy thing here. And then what we do with this genetically modified virus, here is my now genetically modified virus. I inject it into a person, it attacks the tumour cell, makes it burst, releasing all its viral particles and all of its bits and bobs inside, and now the immune system can see me. So viruses are a type of immunology kind of treatment because it's all about making your immune system now recognise this cancer cell. Because remember, cancer cells, they can hide from the immune system. And all I'm doing here is popping the cancer cell with the virus so the immune system can now see it and destroy it, hopefully. Not a Robot has put, will this make more viruses? That's a good question. So we use special types. We can't use any type of virus for this. It has to be a certain type of virus with favourable characteristics, right? So it has to be, we have to be able to manipulate it very easily. But these will not make more viruses. These viruses have been genetically modified in a way that they won't replicate in your body. They won't cause a disease. So all they do is seek out the tumour cell and make it burst. That's all it does. And we've genetically modified it to do that. And there is only one virus that can be injected into a human right now. If you guys want to Wikipedia this after the lesson, it's called TVEC. And this is the only virus that we can use to currently treat skin cancer with. And this is it here. So if you want to go and wiki it, that's the only one we can use in a human at the moment. Now, my question to you is, can I genetically modify myself? Is that allowed? Could I do it? Sarah Shackleton's put, you're not allowed to. Not a Robot, 1997. What do you mean clone? Am I not allowed to clone myself? We've got a mixed bag of results here, guys. Can I genetically modify myself? Vendable Sugar, you're probably the closest with probably. Not a Robot's put clone, then modify the clone. So the answer is yes and no, okay? So yes and no. But to understand why we can and can't genetically modify ourselves, we have to look at the two different cell types in our body. Mears91 has put, it's not too old of a process, so maybe the laws don't exist yet. I will tell you why in a minute, Miz. There are laws about genetically modifying humans. So, I can genetically modify myself, but I can only do a certain type of cell in my body. So you have two types of cells in your body. You have your egg and sperm cells, and then you have everything else. Skin, eyes, hair, liver, heart, lungs, spleen, muscles, everything else. And then your egg and sperm cells are different. Why are your egg and sperm cells different to every other cell type in your body? Why is that? So we are allowed to genetically modify these cells, skin, muscle, heart, liver, but we are not allowed to genetically modify egg and sperm cells. Not a Robot and Vendable Sugar, together you have come up with the right answer. So Not a Robot 1997 has put gametes. Correct, they are gametes. Vendable Sugar has given you the second half of the point. You've put it can affect future generations. Yes. So you are not allowed to genetically modify egg and sperm cells because they are gametes, and anything you do to these cells will be passed on to future generations, okay? So you are not allowed to do that. And now I want to do a little bit of a discussion with you guys. I want to do a for and against kind of genetic modification of human embryos. Mears91 has put, what's a gamete? A gamete is just an egg and a sperm cell, and when they come together, they will make a human baby. Yeah? Your, like, two skin cells together won't make a baby. So, I want to know from you guys in the chat, for and against, why should we be allowed or not allowed to genetically modify egg and sperm cells and gametes? So, and this whole thing is called bioethics. So this is the ethics to do with kind of biological advancements in like health and disease and stuff. So Not a Robot has put, couldn't it be used to stop hereditary diseases? Yes, that is a good point. So I'm going to put, shall we put it in the 4? I'll put it in the 4. So we could potentially stop certain diseases. Oh my goodness, my pen is so slow. I'm sorry, guys. It's really laggy. I don't know why. Maybe because I've got so many tabs open. So I'll put, we could stop, my pen is so slow, diseases. Vendable Sugar has put, you can't make a decision for somebody else. True, but then I never chose to be born, did I? And I was still born. My mum and dad still made me. I never had a choice about whether I wanted to be a Hannah in the world. So we could put that. Maybe we could put consent. I can't consent, or the egg and sperm, I guess, can't consent, and that will be a human in the future. Sarah's put a 4. You can modify genes that could cause a hereditary disease. True. So I'll put genetic diseases underneath that one for the 4. So why else is it a good idea for me to genetically modify? Ooh. So a couple of other points. You said that it's going to prevent diseases, which is really good. What about, oh, someone's put a good one in the chat. Oh, Mears. Mears has put, I'm playing God. Not a Robot has put, it's not ethical. What about things like risks? Do you think genetically modifying egg and sperm has been done a lot and we know exactly how to do it? And maybe what if something goes wrong? Yeah? So are there risks? Is genetically modifying an egg and sperm predictable? What if something goes wrong? Okay, so I'm going to put unpredictable as an against if my pen decides to write for me. Unpredictable. Sarah's put against, it decreases the gene pool. Oh, I like that one. Yeah, decreases gene pool. Eventually we'll all just be clones of each other if we start to genetically modify ourselves. People might make, designer babies. That's a good one. And wealthy people might have an advantage. Exactly. So I'll just do a pound sign for money. So let's say we can genetically modify egg and sperm, and I want a blue-eyed baby with blonde hair. I want them to be 5'11", really clever, but it's going to cost me £20,000. What do you think that's going to do to, what do you think that's going to give rise to? I will leave it out there. But Sarah's put a really good point that wealthy people would have an advantage if this type of technology was available. Mears Against has put it's expensive and rich people will create a super species. Yes. So all these are a really, really good point. Really good point. Dripping Guru has put, is this a course in school? What's going on here? It is. You should be learning about this in school. You should be learning about for and against genetic modification. So we've got some for, we've got some against. So yes, it can help to prevent lots of diseases, but on the other hand, it's unpredictable, it's going to cost money, we might give rise to designer babies. So currently, just in case any of you are planning to do some genetic modification, it is illegal to genetically modify egg and sperm cells. It's against the Human Rights Act, so you are not allowed to do it. But I've already said that we're allowed to genetically modify your normal cells, and this is another type of cancer treatment, coming back to genetic modification. So I've said we can genetically modify your normal cells, non-egg and sperm, and this treatment is called CAR T-cell therapy, if you've ever heard of it. Robot97 has put, how are you supposed to modify your own cells? You do it in a lab. You get a scientist to do it. So I'll tell you right now. Someone's put, Zluman000, if people want babies with blonde hair, who is that hurting? Serious question. Well, it gives rise to what you want to do with this technology. So if this technology is available for, let's say, preventing serious genetic conditions, it might warrant genetic modification. But if people are just going to use it to like change hair colour and eye colour, just because they can afford it, you know, that will be passed on to future generations, and it raises really difficult questions about the rise of designer babies, or people being able to pay for a baby to look like whatever they want to look like. So it's a very difficult conversation, and I won't stop taking me off track, guys. We need to talk about CAR T-cell therapy. So CAR T-cell therapy is a type of cancer treatment. So it's to do with your T cells, and your T cells are a type of white blood cell. So these are the cells in your immune system that seek and destroy, and they eat up bacteria and any kind of pathogen in your body. So what you do is you collect T cells from your blood, give them to the scientists in the lab, and they genetically modify your white blood cells to become CAR T cells. Think of these as like super T cells. Then we grow them up in the lab and we pop them back into your body, and then these souped up T cells will find and attack your cancer cells. So this is a type of genetic modification of your cells that we are allowed to do, and we use this for cancer treatment. And if you guys wanted to learn a bit more about it, there's a really good documentary on BBC iPlayer called War in the Blood. I've popped it here. And this is about CAR T-cell therapy, like a trial they had going in England. It's really, really interesting. So what T cells are is, normally your cancer cell hides from the T cell. But after it's been genetically modified in the lab, your T cell can now recognise all of these special proteins on the cancer cell and then kill it. The last thing I want to introduce to you guys is a type of cool research to do with brain cancers. So, has anybody heard of this? This is the blood-brain barrier, shortened to BBB, okay? The blood-brain barrier is a special barrier that exists in your brain, like over the surface of your brain, and it stops things getting into your brain. Why would humans have evolved this blood-brain barrier? So why do you think humans have evolved a special barrier so only like oxygen and sugar can get in, nothing else? Why have I got a special barrier across the whole of my brain? Why do you think I want to do that? Mears has put to keep the baddies out. Yeah, pretty much. So the blood-brain barrier exists to just let things like oxygen and sugar into your brain and nothing else. So things like bacteria and viruses, even drugs, none of those can get past the blood-brain barrier because we want to protect the brain at all costs, right? So my question to you is, if I've got this blood-brain barrier, like stopping pretty much everything getting to the brain, how do I get cancer drugs into the brain? If I've just said that we have this special barrier that stops things getting into the brain, how do I get the special drugs that I need into the brain? I want to know. No big needles or anything, guys, don't worry. Mears, physically, how would I get them into the brain? Mears91 has put, inject them up the nostrils. Bendable Sugar has put, inject it through the layer. Do you think that would be dangerous? Special. Zluman000 has put specialised vector. No. No vectors. Zluman, what do you do? How do you know what a vector is? So, picture of a brain coming up, guys, just to warn you, a real brain, in case you're squeamish. Oh, Miz has put, can I use the proton laser from last time? Yes. So, this is a special wafer here. And this wafer, you can see the man holding it up with a pair of tweezers. This wafer is about the size of a 5p coin. And it's full of chemo drugs, okay? When you have surgery to remove a brain tumour, and I've taken out the tumour, I want to make sure that there are no cancer cells left in that hole that I've just left. So what I do is I put all these wafers that have the drug, the chemo drug, into the hole that I've just scooped my tumour out of, and I leave them there. So what these little wafers will do is they will slowly release their drug because they've been left in the little hole inside where I've just removed your tumour, right? And I thought these wafers were really cool, but wafers aren't great. So people now have developed a special paste, almost like a glue. So once you've had surgery to remove a brain tumour, you can put this special glue into that hole that you've just created, and that glue, that paste, will release all of that treatment. So Mears has put, does that kill anything that was left behind? Yeah, that's the idea, Mears, is that any cancer cells that are stuck around the edge or that we've left behind by accident, because remember, we can't scoop everything out because we don't want to be cutting out massive parts of our brain for obvious reasons. These little wafers will stay in there and slowly secrete more chemo drug to hopefully kill the rest of the cancer cells. Just want a time check. Oh, it's thundering, guys, outside my house. Cool. So let me pop you back to my camera and we'll stop there because I'm just on time. So today we have learnt how we can use wafers to hopefully treat brain cancers better and leave some drug in there to kill the rest of the cancer cells. We've spoken about bubbles, how bubbles can treat cancer, and how viruses can treat cancer, and why it is illegal to genetically modify sperm and egg cells. So don't do it, guys, okay? You're not allowed, it's illegal. So that is the end of the 4-part series of cancer. And the only reason I did it is because that's what I do for my job. I do cancer research. So next week and going forward, I'm just going to be picking super random, cool topics to chat to you guys about. Next week, we're going to be doing, can blueberries help you live forever and ever, or maybe live longer? So we're going to be doing like the science behind superfoods, and is a superfood real? Is it a marketing term? Is there such a thing as a superfood? So I will love you and leave you guys because I need to go to the loo now, and I will speak to you next Tuesday at 4 p.m. Goodbye, see you next week.